Hello, this is your question 9 in June 2022 Edexcel paper 2, where you have a model, a real life model with a trigonometric function. And I know some of you are confused with this question. So you have Ferris wheel, the height above the ground age of a passenger on the Ferris wheel t seconds after the wheel starts turning is modeled by this equation, yeah, where we have h is the height, t is the time, and b, alpha, and a are constants. Yeah. Figure 5 shows a sketch of the graph h against t for one revolution of the wheel. So this is what the height is doing with time. So this is one revolution. It goes up to here. Given that the maximum height of the passenger above the ground is 50, passenger is 1 meter above the ground when the wheel starts turning, and the wheel takes 720 seconds to complete one revolution, we have to find a complete equation for the model. So we have to find exact value of A, exact value of B, and alpha to 3 significant figures. So we are going to use these 3 things to find our 3 constants. The first one is quite simple because it says maximum height of the passenger above the ground is 50. This function is going to be maximum when sine of the angle is 1, because that's the maximum value of the sine of an angle. So that means that h is going to be 50, and this is going to be 1. So a is going to be a. So my h maximum, my maximum height, is going to be a, because sine is 1, and they say it's going to be 50. So a is going to be 50 meters. We are going to put the units. Then the next thing they say is passenger is 1 meter above the ground when the wheel starts turning. So when t is 0 at the beginning. So I know h is going to be 1 meter when t is 0. So what I'm going to do is to substitute in my model h by 1, and then I have absolute value of 50 sine bt. Time is 0, so remember the function is here. T is 0, so this bit is 0, and then I have alpha, sine of alpha, sine alpha. Sine alpha is going to be 1. So that means that sine alpha is going to be 1 over 50. We do that with a calculator, just sine minus 1 on 1 over 50, of 1 over 50, and we get alpha, which is 1.15 degrees to 3 significant figures. That's what they ask, 3 significant figures. Yeah. So this is the next one. And then to find B, we have to use the last condition. They say the wheel takes 720 seconds to complete one revolution. So remember, sine alpha, or sine theta, any sine theta, is periodic, and the period is 360. It means that every 360, the graph repeats itself. So if I have my function, sine theta, remember is doing this. Is doing this over and over, and this period is 360, but we know we have the absolute value, so that means every negative part of the graph is becoming positive. So this is going to be this, well, roughly, it's not a great graph, and this is 180. So my period, the time, the angle in which the graph is repeating is 180. So if my graph is h 50 sine bt plus 1.15, because this is what we know so far, it's going to be repeating every 180 degrees. So this that I am adding to my first solution is going to be 180. Yeah, so every 180, every time I add 180, I get the same answer for h. I get that my wheel is at 1 meter. So it's going to be 1 meter here, it's going to be 1 meter here, 1 meter here, and so on. They say the first revolution is 720 seconds. So I'm going to write that pt is going to be 180 because it's repeating, my function is repeating, getting the same answer for h every 180 degrees. They say the first revolution is completed when t is 720 seconds. So what I'm going to do is to substitute here, and I have that b times 720 is 180. And therefore b is just 1/4, just dividing 180 by 720. So that's my the last value that I needed to find. So if I want to see the next time, I just add 180 and 180 and 180, and I can see every time the wheel turns 1/4 circle. So my model, if I write it properly, is going to be h absolute value 50 sine 1/4 of t plus 1.15 degrees, and that's the equation that I have to find. Yeah, so I found all the values. And then for b, they say explain why an equation of the form this one, which is exactly the same, but I am adding here a positive constant. So this positive constant, well, would be a more appropriate model. This positive constant is helping me to have like an initial height. So the passenger is not jumping in the ground, is at a positive height, which will help with this initial position, really. Yeah. So this is adding an initial height to my model. It's just doing that. Yeah, and it's 1 mark, so don't overcomplicate. You can say that D would help to have an initial height for the model. Yeah, that's that. And this is all with this question.